Now let's look at example 2. Example 2 is nice because it's already in factored form. So finding our zeros is very straightforward. Let's start with that. Right here, if I set that to 0, that would give me x equals 0. If I set this one to 0, it would give me x equals -3. And if we set that one to 0, we get x equals 1. However, remember, this is really saying x minus 1 all squared. So that x minus 1 factor shows up twice, which means our root of 1 will also show up twice. So this has a multiplicity of 2. Okay, so our zeros, I'm just going to put them in order, are -3, 0, and 1. -3 has a multiplicity of 1, 0 has a multiplicity of 1, but 1 showed up twice, so it has a multiplicity of 2. What that means is odd multiplicity, so we will cross through there. Odd multiplicity, so we will cross through there, but even multiplicity, so we will touch at that point. Now let's go back to do our end behavior. Our end behavior, remember, is looking at our leading term. But we have to remember it's looking at our leading term when we're in standard form. This is not in standard form. So we know that our leading term will be negative. However, is the power really a 1? No, the power is the total altogether. So we really have a 1 here, a 1 here, and a 2. So our total degree is 4. So our degree is 4, and we are negative out front. So remember, when it's a degree of 4 and negative, that means we're going to be down, down. So as x goes to -infinity, f of x goes to -infinity. And as x goes to +infinity, f of x still goes down to -infinity. It's down, down. Okay, so let's sketch what we have so far. Again, we have our 0 of -3. I'm just going to have each one be 1 unit. So -3, 0, and 1. Okay, we know that that end behavior is going to be down and down. And I cross through certain zeros and touch certain. So again, I'm just going to make a little rough sketch, and then we'll fix those relative max and mins. So I know the graph starts down, and we have an odd multiplicity at -3, so it's going to go through -3. I'm going to have to come back down and go through 0 because it had an odd multiplicity. Now I'm going to come back up, but this time I don't go through 1, I touch 1 because it has an even multiplicity, and I come back down. And that is really important that I just touch there, because if I'd went through, I would have an end behavior ending up. And remember, we want our end behaviors to both be going down. So this is the general gist of this graph. But now what I want to do is create a table and estimate those relative max and mins to be a little bit more accurate. So let's start with estimating this guy. Should it really go a lot higher? Should it go lower? Etc. So let's try that, see if it actually even fits on our graph. So remember, we have our first 0 at -3, and our next 0 was at 0. So I'm going to test -1.5 because that's about in the middle. Okay, so I'm going to take -1.5 and plug it in to our polynomial here. So we have -1.5 times -1.5 plus 3 times -1.5 minus 1 squared. Again, I'm just going to confirm that I don't have any typos in here. Okay, and that gives me 14.1-ish. So as you can see here, this is going to go far off the graph. So instead of counting by ones here, I'm going to count by twos. So 2, 4, 6, 8, 10, 12, 14. So at negative 1.5, I'm going to be a little over 14. So now I can see that that graph really went up high. And now it's going to come back down through 0. Okay? Now we have to work on this area. So what I'm going to check on is, again, somewhere about in the middle, maybe a little closer to the left. Since I know this doesn't go right through, it's going to bounce. But again, we're just approximating. So I'm going to plug in 0.5 next, because 0.5 is in between these two zeros. So when I plug in 0.5 into my equation, we will have the negative out front, 0.5 times 0.5 plus 3 times 0.5 minus 1 all squared. And again, just confirming I don't have any typos. And we get negative 0.4 about. Okay, so since I'm counting by twos going down, that negative 0.4 is going to be quite low. And then we will come back up. And again, my end behavior ends down. So here's approximately what the graph will look like. Now I'm going to fix that relative max and min. Remember, our relative max we have up here, and that was at the point negative 1.5, 14.1. We have a minimum somewhere down here, and that is at about 0.5, negative 0.4. Again, this may be off by a tenth or two. That's fine. We're just estimating, okay? And then if you notice, we bump back up here. So we do have another relative max, and that is right here at the 0. And so that is at 1, 0. Now, one other additional little detail is if we look here, our highest point is this point. So this is actually called an absolute maximum. And this point is the relative maximum. For our minimums, we go down forever, so this will just be our relative min. We do not have an absolute minimum, because negative infinity will end up being our minimum. Okay, so that's just a little extra information there. One more thing, I forgot to fill in our y-intercept, but we can see we crossed right at 0, 0. And so I'll just zoom out here so that you can take a full look at that problem.